Hi friends, it's Rishi from GView. Good analytics and insights rely on good data. Behind every pretty dashboard, there lies hours of sweat and tears in cleaning and preparing data. Today, we will explore the capabilities of large language models like GPT-3 and GPT-4 in helping us clean, enrich, and prepare data for downstream processing. These capabilities do not generate headlines, but I believe that they have the potential to drive significant cost savings and help companies make the most of the data that they already have. The problem that we are looking at today is cleaning up and enriching location data. This is a pretty common use case. Let's imagine we're dealing with user-generated content, perhaps the results of a survey or form, or maybe you're dealing with a bunch of messy addresses. Now, this is a fairly typical data engineering problem, and there are many techniques that have been built over the years to deal with these type of problems. The use of regular expressions, third-party APIs, and information retrieval techniques. However, today we will build a prompt that will allow us to use the natural language understanding capabilities of large language models to help solve these type of problems. We will give the model ambiguous data corresponding to a location and get it to return to us the canonical version of that data. For example, if I give the model NYC, I'll get it to return New York City, New York State, the USA, i.e. the place name, the state, and the country. We'll explore this problem using ChatGPT, but we have developed similar features using the OpenAI API. I hope you find it useful. Okay, so here we have ChatGPT open. We're going to do this experiment using the GPT-4 model. I've put together a prompt already, so let's start with that. So here is a prompt. Your useful assistant helping with some data normalization and cleaning work. You'll be working with location data. The input will be a string that might correspond to a location, and your task is to take the input data and return me the place, state, and country that corresponds to the input. Use canonical name for the places, and then we clearly specify what the output format should be. And we also make it very clear to only return the JSON output. Now, to make the most of large language models' capabilities, we also want to give them some hints on how to deal with ambiguous data. So here we say, case of ambiguity, make a best guess for a reasonable value. If that is not possible, return unknown for the corresponding key. So let's see how this model works. So first thing I'm going to do is give it NYC. Okay, there you go. It's behaving as expected. City of New York, State of New York, country of United States. Let's give it something different. So we say Vadodara, Gujarat. This is a city in India where GView is headquartered. Great place. So it says City Vadodara, State Gujarat, country India. Now, Vadodara also used to be known as Baroda, and that name was changed maybe 25 years ago. So let's see how ChatGPT deals with ambiguous data. So I'm going to give it Baroda, Gujarat instead. Okay. So here you can see that the model returns to us the canonical name for the city, which is Vadodara. So we are going to give a few more examples. So let's say Arlington. Arlington is a very common city name in the US. There's an Arlington, Texas, Arlington, Virginia. There is an Arlington, Massachusetts as well. What the model will do in this case will return the most commonly occurring place, which is Arlington, Texas, in its data set. So now, let's give it some examples to give it some more guidance. So here, we've given some examples. So we've used our usual, a couple of the examples that we've seen already. We've also given it some examples for where we just give it a country and it has some missing information. And we also gave Arlington as Arlington, Virginia. So now let's give it Arlington. There you go. And now it generates Arlington, Virginia. So here is an example of us being able to give pretty ambiguous input. So we can even say London, Ontario, for example, and it'll give us London, Ontario, Canada. But if we just give it London, it'll give us London, England, because London, England occurs more often than London, Ontario. These are the types of issues, or these are the types of nuances that we need to think about when using large language models for doing these type of data normalization and processing tasks. The other thing that we can also do is, instead of giving it a single output, especially in an API call, we could probably give it an array of inputs and get it to generate an array of outputs. This could be a lot more efficient in terms of cost, because remember, every single API call involves a cost. So there are a bunch of different optimizations that we could do to make the model behave better and to also be cost effective. I hope this was an interesting exploration.